My name is Borzoo Mardani, and I'm working for the Megger company as a territory manager responsible for the monitoring, which is include the smart sensors. And today I'm going to talk about how grid sensors can assist utilities and DSOs with the high level of the DER, and how smart sensors from Megger can help on this area, and how Megger can help on this area. Today, the distribution networks are looking for the supply reliable power. Aging the networks, extreme weather events, renewable energy resources, and then a new demand on the energy networks can have an impact on this network and may lead to the outage. Digitalization, as we mentioned it on the electrical industry, is opening the key to collecting the data from the information and helping the utilities to make a better decision and have a better visibility. That's why Megger provides a solution that's collecting the data from the network, analyze the data, and give them better visibility of the network, and which utilities can reduce the power outage and can reduce the risk. We introduced the smart sensors called MS5000 for the overhead lines. For these purposes, some of the key features of the smart sensors is like the reliable fault detection, including high impedance faults, which we talk about it more later. Detect the faults which cannot be detected by the prime protection system, or it's not the policy to detect it by protection system in the primary substation, like high impedance fault or cutting wires. It's the predictive analysis of the network, ability to identify the weak spots, a large range of the periodic measurement, including power quality parameters, supporting the secure cellular and mesh radio communication, operate from the very low line current, as low as a 1.5 amps from the line, and supporting the line voltage up to 100 kV, and can be integrated with the utilities control room software. Sensors periodic do the measurement continuously, each 5 to 15 minutes, according to the customer request, and it's measuring the more than 35 parameters from the networks, and each parameters will be saved on the sensor server and the software. This measurements includes the load current, voltage, phase angle, power factor, active reactive power, energy and total energy, voltage and current harmonics up to 30th, and the total harmonic distortion, phase representation, zero sequence data, voltage and current imbalance, some diagnostic information for the sensor itself and the area around, some alarms and notification, and plus waveform of disturbances like impulses and arcs. Sensors is designed including two high quality CT, one from the measurement of the current from the network, which is up to 600 amps with the accuracy of the 0.5%, and the synchronization between the sensors of the 30 microsecond typically, which is this enable the sensor to find a zero sequence. And another is for the it's a highly efficient power harvesting from the line, as well as the 1.5 amp, another cities. It's designed for the operation up to 20 years in the network, be maintenance free with the IP67. Material is the UV fiber resistance polymeric composite material. And with the aluminum covers, it includes two stainless steel. The main one is for the conductor, and then the secondary for the sensor itself. Each sensor will be tested in the factory by an electronic fault tester, as well as for sealing. Sensors can be installed on the live line by using the short and longer sticks, and also by using the high voltage gloves. The principle of the operation sensors normally provided instead of the 3 for 3 phases and distributed in the network, and then they send the information sensors constantly record the current and voltage information, and once the outage or the other anomalies occurs, the data collected from the sensor via IoT system, then they will send this data to the MetroView software for the analytics. And for the area that there is no cellular coverage, we can provide the gateway, which is called MS310, or the router. Any data coming from the sensors or a gateway is securely communicated to the cloud utilizing private APN and end-to-end encryption with the TLS and SSL. And then you can get the information from anywhere and anytime. And also this can be installed beyond the firewall of the network utilities and can work with the automation system of the network utilities like a SCADA system. As we mentioned, if there is no cellular coverage, we can provide the gateway or router for more coverage up to 100 kilometers and working with the 100 of the set of the sensors. And this one is designed to the work in the network for the minimum of 10 years. Megger solution is comprehensive. The algorithm is covering all type of the earthing system, like the solid grounded, floating, neutral, single wire earth return, and Peterston core. It's working with the aluminum and copper overhead line conductor. Its coverage is cellular and mesh radio communication. And optionable is for the fully flexible cybersecurity integration with the DMS using a DMP3 and IEC 104 protocol. Who get benefits from the smart sensors? Line technician and the line engineer, by reducing the wildfire and then the risk of the electrocution, reducing the search time and cost for them, and identifying the broken conductor and vegetation problems. Area manager, give them the more grid visibility, overload, direction of the power flow, power theft, power active and reactive power information. Analytic predictive maintenance, they can identify the weakest spots, the broken conductors, missing phases, harmonic problems, and other things. And then you can improve or reduce the CAD, safety, customer minute loss, and then operation and maintenance cost. Innovation engineers can use it to create a new system to detect the pre-false study and analysis of the DR and power flow and electric vehicle load management. Asset management can use it to improve the network reliability, lifetime, condition monitoring, and asset performance management. Standard and policy managers for the load management, protection policy, lightning management. And then procurement management for the planning for the investment, and then reducing the cost. And mainly the public, people, and environment get benefit from the sensor. As we mentioned, the sensor send the information to the software called MetroView software. We developed enormously the MetroView software during the last year and improved the software. And we are ready to have provide a different session for the MetroView software. But briefly, I'm going through some benefits of the MetroView software, how it's get. The main menus gives lots of information, like the fault events dashboard, analysis of the screen, analysis of screen, alarms, reports, customized daily chart, daily, weekly, yearly, waveform graphs, electric schematic of the diagram of the networks, map view, data tables with all the information, setting and configuration, min and max graphs, pre-cycle analysis, including vector diagram, positive and negative and zero sequence, harmonic and waveforms. This is some examples of how the MetroView software looks like the waveform analysis, give the three-phase voltage and current waveforms, plus the zero sequence for the high impedance fault detection and the direction of the fault. It's give you daily graphs to get more analysis and load management. Fault location, it shows which part of the network is the faulty one and which sensors sense that fault. Dashboard of the faults is give the data of the faults during a period of the time, for example, 1 year, compare it with the weather condition, rain during the year, and it provides the heat map, which is by analyzing the faults is showing which part of the networks having the most faults, which enable the utilities to plan for some maintenance or the other things. MetroView in general add a value to the sensor in 4 areas, like the periodic data, by improving the network visibility. Comprehensive fault log is enabling the utilities to finding the faults faster. Grid analytics, identifying the network weak spots, and have a notification, alarm, and self-monitoring metrics. This is the informing the utility staff to get some action and do some necessary things. As we mentioned, is generates 28 daily graphs for the voltage and current, and for each feeder and sensor, you will have the 28 of these graphs, which give you more visibility of the network and can get the more analytics information. One of the examples for the power flow, this is the 5 sensors installed in the Norway to connect the 2 of their wind farms to the main networks, and then transferring the power from the north to the south of the country, which is the main station is. And as you can see, for the sensor 1, when the wind farm is, the minus normally means the importing from the network, and plus means the exporting to the network. And here is always importing from the network, while at the same time, when the S5 is recording, which is the main substation, is during the 1 day they have a 4 peaks, which means 4 times they change the importing and exporting from the network, which is they enabling them to make a decision and manage the load management and the power flow in the network. It provides the pre-cycle analysis for the phasor diagram, which is give you the voltage and current and phase angle, and also provide a 0 sequence, negative and positive sequence, and enabling the utilities to have more information about the high impedance faults mainly. It's measuring the harmonics, current and voltage, and total harmonic distortion and harmonics up to the 30th. And this enabling the utilities to identify the power quality problems. Mean and max load profiling. This can be configurable daily, weekly, and yearly, and can be downloaded in the Excel files in some areas which they don't have in rural area, they don't have in old substation some monitoring system, and they want to do some investment planning or changing. They're using this profile to make a decision which part of the network needs to be replaced. And the sensors creating the periodic data, and all the time they are monitoring for the faults, and they're recording each fault. And by clicking on the top of the software, you can find the time, which is the black one shows the normal operation of the network, and the red one recording the faults. And by clicking on each red dot, you will get the fault information. This includes which part of the network is faulty, and then which sensors is sensing this network. And then this can be sent it to the utility DMS. Fault dashboard defines the 3 types of the faults, which is the yellow for the self-extinguishing faults, which is just a power interference without any power down. Transient fault, orange, as a A fault event resulted in the power down for a few seconds or the power blink, and then permanent fault, which is the fault event resulted in a longer power down. And you can select each type of the fault you want to monitoring, and slew rate of the each fault will be showing, and all the current and average and peak current information of the each fault with the waveform will be showing in the software. This is an example of the fault. It shows the type of the fault, like face-to-face, and three-phase fault, showing the waveforms of the fault. For example, this one is between phase A and C. Another example of the fault, which is the face-to-earth fault, and it's a transient fault. And by zero sequence fault algorithm, they can find this is the high impedance ones, and they can find the faults up to 10 kilo ohms. And as mentioned, it shows the average. For example, for this one is now 9.7 amps, peak is the 134 amps, and slow rate of the 64 amps. And all this information will be recorded in a data table of the fault. The fault log recording all the faults is happening for the period which you can choose it for a month, year, and more than that one. You can choose and it shows the date and time of the fault and which phases is happening, average current, peak current, and the slow rate of the fault. And by clicking on each fault, you will get the more information, like which part of the network is faulty, waveforms, and other type of the information. You can use the fault for finding the weakest spot, and it's give you the analytics for a period of the time, which part of the networks have the most faulted, and then which parts need more investigation. And it's enabled to detecting very short fault, like in the cable termination and installation, and then other type of the faults. This is an example which is the installed in the UK one utility using the networks for the vegetation problems. This is the installed the sensors in the wooded area in the UK, and another one they installed in the open farm fields with the very few trees in. And this is the what the sensors and Metro View software is recorded. And if you look at the fault dashboard for the wooded land vegetation, each of these bars shows 2 months, start from the January, February, and we can see during the summertime in the wooded land, when the vegetation is growing, the transient fault is growing as well. While in the farmland, there is no transient fault during the summertime, but during the January, February, and the November, December, when it's the high wind in the area, the permanent fault is growing. That is helping the utilities and managers to make a decision about, like for the woodland, to do that. There is some trimming during the summertime, and then during the winter time, they can do the pole strength test and other things. And another example of the vegetation high impedance fault, this is happening on the Peterson coil earth network, which is this earthing system distinguished the fault, but the sensor recorded the fault and showing this is the vegetation problem, while the protection system is not catch this kind of the fault. And it's showing the fault log, which is showing each fault is happening in the network. For example, on this system, there is some transient fault is recorded on the phase C in the middle one. And if we are not looking at this one, this may cause for the one permanent one. That's how the smart sensors and the software is helping for the pre-fault detection. This is another example on the damage installation in the rain, which is the intermittent fault. And again, this is on the Peterson coil earth test system, which is they distinguish the fault when it's happening immediately, but sensor is recorded the fault. And if you are not looking at this one as a temporary fault and not doing the more investigation, this can be caused as a serious fault, and shut down the whole network. Additional things is notification, alarms, and self-monitoring metrics. Sensors can be set as sending the notification via the SMS and the email to the line crew, and it shows the time and date of the fault, type of the fault, which sensor is feeling it and sensing it, and the direction of the fault. You can set the alarms like the overcurrent, power down, and voltage imbalance, and some self-monitoring metrics like the missing periodic data, GPS coordinate mismatch, excessive trigger or no trigger events. Here are some feedbacks that we are receiving from our customers. Like I said, it's been a huge relief for us knowing we have the sensors to rely on for finding faults during the winter. And other customers is mentioning reducing the switching operation, like connecting the renewable sources to the network. Reducing search time, improve the staff and public safety. MS5000 linked to the DMS enabling remote fault location and saves more than 120 minutes on persistent earth fault. And the same, another customer in the UK mentioned the same, they reducing the searching time by 16 to 120 minutes. Many small primary substations have no online load measurement in DMS, and they are just using it for a short time, the system for the online measurement and load management. Customer minute loss or SAIDI can be halved in the worst performance feeders, and ability to reference a disruption clearly to customer and investigate customer complaint. And Megger is not only providing the hardware and software. We are also offering consultative support prior, during, and after the sensor installation. Our service contains a worldwide support structure available both locally and remotely to help with every step. Flexible software and server support option, including DMS integration, expert knowledge of the cybersecurity hardware and software, and ability to test or service with a smaller scale project prior to larger investment decision. There is more information in our website. You can visit, please visit our website. There is two websites, megger.com and solution.megger.com, with some articles, case study, and videos.
Perfect. Thank you, Borzoo. We had this question during the previous session, but I wanted to give this one to you as well. And it relates to cybersecurity. With the increasing digitalization of the grid, some will be worried about potential bad actors targeting our critical infrastructure. So how do you ensure our grid remains secure while implementing more digitalization?
These systems can be completely installed into the grid networks with all the cybersecurity things and installed with all their system they have.
Okay.
If the networks is asking us, we can support on that one, do some consultancy support on them, but can be installed in their network, which is they have their own networks.
Yep. Perfect. We are actually running a little bit over, and that was the main question that I had. Thank you, Borzoo. That was
Thanks.
that's a lot of information, so really appreciate that.
Thank you very much.